In 1994, astronomers pointed a telescope at a patch of empty sky and found a galaxy being torn apart in slow motion. Not exploding, not collapsing, just quietly unraveling, stretched into a ribbon of stars so faint we almost missed it entirely. That discovery cracked open a question nobody had thought to ask. What else are we missing? Today, we are to find this question, so let's start. When two galaxies collide, or a smaller one gets swallowed by a bigger one, they don't just disappear cleanly. They leave debris, ghostly trails of stars, faint rippling shells, long tidal tails, like cosmic scar tissue. Think of it this way. Imagine throwing a handful of glitter into a river. It spreads out, stretches thin, and leaves a trail. That's basically what happens to a galaxy when gravity tears it apart. These remnants come in a few flavors: stellar streams, long ribbons of stars, tracing where a galaxy used to be. Shells, concentric ripples around an elliptical galaxy, like waves frozen in space. Tidal tails, massive arcs flung out during galaxy collisions. And ultra-diffuse galaxies, enormous in size, but nearly empty of stars. Milky Way-sized with almost nothing inside. Here's where it gets wild. Our own Milky Way is cannibalizing a dwarf galaxy called Sagittarius right now. It's being stretched into a stellar stream that wraps completely around the galaxy, over 100 degrees across the sky. Andromeda, our nearest galactic neighbor, has a giant stellar stream, the leftover trail of a dwarf galaxy it devoured millions of years ago. Then there's NGC 1052DF2, a galaxy so faint and diffuse you can literally see through it to the galaxies behind. And here's the kicker: it appears to have almost no dark matter. That breaks basically every assumption we had. And Dragonfly 44, a galaxy the size of the Milky Way that produces only 1% of the light, a massive dark matter ghost with barely any stars. These galaxies don't just randomly fade. Something stops them. But what are their culprits? Let's understand it by some examples. Take ultra-faint dwarfs. The culprit was the universe itself. About 13 billion years ago, the first stars flooded the cosmos with radiation so intense, it literally boiled away the gas from the smallest galaxies. No gas, no new stars. Frozen in time ever since. Larger ones in galaxy clusters get their gas vacuumed out as they fall through hot intergalactic plasma, a process called ram pressure stripping. The cluster kills them. And some, like those dark matter-free galaxies, two dwarf galaxies may have collided at high speed. The dark matter passed straight through, while the gas and stars stayed behind. A cosmic collision that literally separated matter from dark matter. These ghost galaxies aren't just beautiful curiosities, they're time capsules. Their stars formed over 13 billion years ago, before most of the universe's chemistry even existed. Studying them tells us what the very first galaxies looked like, and what the early universe was made of. They also help us map dark matter, because the shapes of stellar streams are controlled by gravity, including gravity from dark matter we can't see. They act like a forensic trail through the invisible universe. And we're solving a long-standing mystery. Cosmological models predicted thousands of tiny satellite galaxies around the Milky Way. For decades, we only found a few dozen. Turns out, the rest were there all along, just turned off, invisible, waiting to be found. The universe is full of things that existed, burned out, got shredded, or just faded. But they leave marks. And right now, with telescopes like JWST, Hubble, and soon the Rubin Observatory, we're reading those marks. For the first time. The ghosts of the cosmos aren't gone. They're just quiet. If you found this fascinating, hit subscribe. We cover the universe's strangest secrets every week.